Hello everyone, this is 2272 Application Technology Group Project video. The theme of the video is the development history and the future prospect of the unmanned driving technology. This is my group member Zhang Shisheng, Chen Wangxian, Pan Hao, Chen Hongxiang, and Ma Wenzong. Okay, let's introduce my content of the project. First, introduce introduction to the driverless car technology. Second is understand unmanned hardware and software systems. Third is novelization of new technology. And the end is conclusion. Okay, let's start.
With the rapid development of science and technology, electronization, information networking, and intelligence have gradually become the big development of trend of the future. Automobile and unmanned vehicle is the best embodiment of this development trend. Unmanned driving refers to the use of vision, ranging, and other sensors on the vehicle to perceive the road conditions. And then the computer makes the decisions according to the precipitation results, and controls the chassis actor to control the vehicle, replacing the operation of the traditional driver with these sensors of the processes.
Okay, let's introduce the history of the driverless cars. In 1984, Draper partnered with the Army to launch the ALV. In 1986, enabled the world's first computer driver class appeared. The Arago test vehicle conducts long-distance road tests in 1998. In 2004 to 2007, held 3 Draper driverless challenge competitions. In 2009, Google announced a team led by Sebastian Sohn, former director of Stanford's Artificial Intelligence Lab, and co-inventor of Google Street Viewer, started developing the driverless technology. Startups represented by Nutomi and Zoxi have entered the field of driverless cars in 2009. In 2013, traditional automobile manufacturers such as Audi, Ford, Volvo, Nissan, and BMW have launched driverless cars in the season. In 2015, Tesla invented Autopilot, a semi-automatic driving system. In 2016, Uber self-driver cars is officially on the road at the Uber Advanced Technology Center. General Motors has entered the self-driving space with its acquisition of the Crusoe Automation. Okay, next is the current situation of the driverless cars. Despite varying degrees of the autonomy, major players are working to integrate more advanced control systems into cars that can interpret sensitive object detection to detect signs or avoid collisions. Currently, most self-driving cars on the market are in Level 2 and 3, which feature advanced driver assistance systems such as collision detection, lane departure warning, and adaptive cruise control, while Level 4 and 5, as measured by SAE, autonomous vehicles are unlikely to gain widespread acceptance. Level 2 and 3 are expected to grow rapidly before the 2030. Fully autonomous vehicles will not reach a broad customer base unless they are completely free of the illegal online control. If these concerns are addressed, the market for autonomous vehicles is expected to grow positively in the coming years. Major automakers, tech giants, and specialized startups have invested more than $50 billion in developing the autonomous vehicle technology over the past 5 years, with 30% of the funding coming from outside the auto industry. As public authorities understand that autonomous vehicles have great potential,
and provide economic and social benefit, they are likely to continue to support the relevant market.
With the technology will drive market growth. The main component of the self-driving cars are sensors and cameras. LiDAR acts as the eyes of the self-driving cars as it can provide a 316-degree view of their surroundings to help the car drive itself safely. Many self-driving cars use it to navigate their environment in real time. Its advantages include accurate depth perception, which allows LiDAR to know the distance to an object within a few centimeters, up to 16 meters. It's also well suited to 3D mapping, meaning the returning the vehicle can navigate in a predictable environment, a significant benefit for most autonomous driving technologies.
CV2X technical specifications are specified in the Rio 14 and Rio 16 5G technical standard issued by Sun GPP organization. We all know that the Internet is about connecting network devices to the network devices, and the concept of the CV2X is that you can communicate directly from car to car. We know in advance the route warning from the vehicle head and the communication between the vehicle and the person transmitting the route information not only ensure the safety of the pedestrians, but also possible to mark the location of pedestrians in our virtual spaces. Communication between the car and the road basic information such as the traffic light to mark parking space and communicate between the 5G network and the cloud obtain operation like high-precision maps. And there are 4 technical frameworks in total, but one of the 2 standards currently being developed is the DSRC protocol based on the Wi-Fi signals. Until the 5G concept emergence, Wi-Fi seemed to be the only technical capable of such as an application. It has been invested in research and development by automobiles.
However, relying on Wi-Fi technology, it is difficult to support high-speed mobile phones all the time. Once the speed is increased, DSRC signals will begin to drop suddenly with the poor reliability and loss, delay, and shake. However, the communication between the vehicle and the human vehicle infrastructure has not reached a stable and usable state. CVRX has completed all the technical defects of the DSRC. On the one hand, it is based on 5G network and has the characteristic of the high speed and the low latency. On the other hand, the cellular network technology based on 5G networks is designed for vehicle mountains and high-speed mobile environments. And so far, China is the only country in the world that has confirmed that it will use CVRX technology, while countries like the US and Europe.
We can actually use the mobile phone that everyone has as a medium to bring everyone into the virtual world to mark. It sounds ridiculous, but it's the fact that now we are inseparable from the mobile phone, and the mobile phone itself, a precision sensor, all-in-one device, GPS, electronic, compression, acceleration sensor, gravity sensor, air pressure sensor, and so on. There will be more in the future. In the area of the fully autonomous driving, the air pressure sensor measures our altitude at this time at 80 meters, while the road outside the average altitude is about 50 meters, so you must not be on the road. At the time you are hungry and go to the convenience store across the road to buy breakfast, and then you get dressed and ready to go out. The electronic compass and accelerometer in the phone know that you are following the corridor you pass through every day. Take the elevator to walk out of the door of the unit. At the same time, the altitude of the outside world has become 51.5 meters. The mobile phone can judge that you have reached the outside. As long as you reach the outside, the system will start to work. The first 3 stages continue to work and actively use the GPS. At the same time, make sure that you are accurate the meter.
At this moment, you have been watching. As you continue to approach the two-way four-lane road, our car on this road will establish communication with your phone based on the CR2V technology and know that you are working here at a speed of 1.5 meters per second. It will appear on the first line in about 10.8 seconds. After 2 seconds, the first car will find you with the 84.8% match with your location information through the laser ranger finder. The processing data is way past the car that it go about the past route. There are still many problems that need to be improved in driverless technology, and 5G is the key to the realization. By integrating with exciting technology, the area of driverless driving will not be far away. Okay, that's all the content of my video. Thank you.